ठीक. So we completed till over here, isn't it? Like one of the most important case we did. What happens when the electric field is varying on the in the direction of normal and perpendicular to the direction of normal, isn't it? So we have two different such methods, two different kinds of integration for that kind of processes. For varying along the direction of normal, I have to just replace the variable, the value of variable, which is given as a coordinate. And for the case of perpendicular to the direction of normal, I have to take into conclusion of considering the particular variation, and then using by the method of integration, I have to do that, isn't it? So we completed these all questions, four parts of the questions, right or not? And we got many values and all. So that's what was your problem. Now let us move on to, we'll do some more questions and then we'll move on to Gauss law, right or not? Okay, so Gauss law, capacitance and dipole moment is left, isn't it? So let us be fast, right or not? Okay, so see, there is a ring, right or not? And on the axis of ring, I'm placing some charge. Okay, on the particular axis of ring, I'm placing some charge, and the ring has a radius r, right or not? Let's suppose the charge kept over here is q, and the radius of ring is r. The distance of charge from the center of ring is x. Got it? Question is, find the flux through. Find the flux through, or let me write it over here. Find the flux through the ring. That's your question. Okay. Find the flux through the ring. Do it. Do it fast. Okay, it's not a ring. Sorry, sorry, sorry. Ah, it is a disk. Sorry, sorry. Find the flux through the disk. Yeah, because ring, it's simple. It's like finding the just the area and then just multiplying it. I'll give you an hint. Let's suppose if you would have been a ring, then what I would have done? I would have just find out the electric field over here due to this charge and multiplied with the area. That's all. That's what my flux is, isn't it? But here I have a disk. Are you able to get me or not? And what happens with this case, there is a big problem. See that if I select the electric field over here, if I select the electric field over here, if I select the electric field over here, so at all these points my electric field is totally different, isn't it? Yeah, so first I need to consider the electric field at the topmost point, let's suppose, and that topmost point is present at some angle theta from the charge. ठीक है ना? ठीक है? Then question arises how to do it. So to do it in a perfect way, we consider two processes. See that. You try by yourself first. Okay. See how to do it. That's why I gave you the example of a ring. See, since this is variable, you think of one case. Let's suppose if I can find this flux through the given ring, which has a very small thickness. Got it? If I can find the flux through the given ring over here, which has a very small thickness, so what can happen? I can just consider that disk is made up of infinite rings or not. Yes. And if I know the flux through one of the ring, I can just integrate it and then I can get the flux over the whole disk. Ring. See. Point is that for a ring, it is very easy to write the flux because the area of the ring is very small. Like we can consider this will be the only means area of the ring is already known, isn't it? And if I can find the flux through this ring, then I can just integrate it over whole disk because a disk is made up of infinite rings, isn't it? So the process step one means consider or consider a infinitesimal ring. Whenever I have told you already, whenever you get the question of continuous body, try to reduce it into its smaller form, isn't it? So consider an infinitesimal ring, yeah. Then you integrate it of thickness dr, ठीक है? हाँ, and located at y distance from origin. Right or not? What I will select? I'll select this ring of some thickness and then I'll say that it is located at some y distance away from, yeah, some y distance away from my center. ठीक है ना? Is that clear? Now, due to this charge over here, some electric field will be there, isn't it? And that electric field will be present by making some angle alpha with the horizontal. Yes. So then this electric field will have once again two component, one perpendicular and one parallel, isn't it? So if that angle is alpha, this angle will be also alpha and this is D. So this will be what? D. Okay, not D, it will be E because charge is kept. We are not distributing. Are you able to get me or not? So this will be E cos alpha and this will be E sine alpha, isn't it? Are you able to get me? ठीक. So let's suppose if I want to write the equation, then you try it. Now you try. After that, I will think. I have given you enough hints. Now you can do easily. Try. It's easy busy. Acha, first thing understand which component will create the flux, E sin alpha or E cos alpha. Srishti, are you here? E cos alpha. Yes, because the normal is along this direction only, isn't it? And E sin alpha component is perpendicular to normal. So therefore, flux due to E sin alpha, lead to as a flux due to E sin alpha is zero. So I have to calculate due to E cos alpha. But I have been given x and capital radius r, isn't it? I have not been given this y variable, so I need to represent something. So look over here, how to do it. See, can I take this tan alpha? Tan alpha will be perpendicular by base y by x. So I can write y in terms of x or not because x is given to us. So x is x tan alpha, isn't it? Okay, acha. Now second point, if I know my y, I can even know this distance of the ring from the charge or not. Why to consider, again we will write y. So instead of considering root over, let us just write in terms of something. I'll show you. I'll call this as d dash. So d dash is what? I can write cos alpha as base by hypotenuse d dash or not. So d dash is what? Nothing but x by cos alpha, which is x into sec alpha. Got it? So represent like this way, because if you are considering a square root, once again you will have to write in terms of sine or cos ultimately. Okay, got it or not? So then look over here. Electric field due to this charge at this point P is what? Simple, 1 by 4 pi epsilon naught, that is K, charge is Q by d dash square. Hi, Gini. So KQ by d dash is how much? X sine x sec alpha. So it will be KQ KQ divided by x square sec square alpha. That's my electric field at that point, isn't it? So now I can define my small flux. Acha, what will be the area of this ring? See, flux is equal to what? A small flux d phi will be electric field at that point into a small area or not? Correct. Now area of the ring is normally pi r square, but I have to take infinitesimal area or not? And that area is varying with respect to radius, so I need to differentiate with respect to radius or not. So I need to calculate dA by dr. So that will be what? 2 pi r, isn't it? So what is dA? dA is 2 pi r into dr. Got it or not? So that is electric field at point P into 2 pi r into dr. Got the idea? So reason for that was, see, first I created my small ring. This is a tough question actually. This is a nice question. So you need to understand that when I need to find for the continuous body, I need to define into infinitesimal terms. Now infinitesimal, I have to look which kind of geometry is that. So here ring has a thickness, not means previously we considered ring as one dimensional geometry because it doesn't have thickness, but here it has a thickness. So I need to consider its area. Are you able to get me or not? ठीक चलो तो look over here d phi, this implies d phi will be electric field at that point, which is kq by x square sec square alpha. अच्छा ये 2 pi r नहीं होगा, रेडियस तो इसकी y थी ना, सॉरी, है ना? तो 2 pi y हो जाएगा, है ना? तो 2 pi y dy. Is that clear? So 2 pi y की वैल्यू क्या है बेटा? x tan alpha and x is constant. So if I take dy, so it will be x is constant, so x will come out. Tan alpha differentiation is what? Sec square alpha. Dy by d alpha will be this or not? So a dy can be just written as x sec square alpha into d alpha or not? So I'll just multiply over here x sec square alpha into d alpha. So see, sec square alpha got cancelled. X got cancelled. This implies d phi is equal to kq into 2 pi integral of tan alpha d alpha. Got it or not? Is that clear? Is that clear or not? Now, achha, now out of this flux, I have only I have the component of electric field cos alpha as only the term over here or not. So look over here. So d phi is only possible 2 pi. I'll write like this way, tan alpha d alpha. So d phi is means the flux is only there for E cos alpha component. So I need to take only the cos alpha component over here. So I need, if I take the net flux, or let it be that only. So if I take the net flux, this implies phi net is integral d phi cos alpha, isn't it? So बस इंटीग्रेशन कर दो. अगर tan अल्फा को cos अल्फा से मल्टीप्लाई किया तो सिर्फ sin अल्फा बचेगा. तो phi net 2 pi into k cube इंटीग्रल sin अल्फा d अल्फा. ठीक है ना? And alpha varies from where to where? Alpha varies from 0 degrees till theta degrees, isn't it? So 0 to theta. Are you able to get me or not? Now I'll decrease its size. So then look over here. So if I do the integration, phi net will be what? I will I'll write in terms of 2 pi by 4 pi epsilon naught. I'll write, put it k value into q integral 0 to theta sin alpha d alpha. That's my term. So this becomes what? This becomes finite is equal to 2 pi cancel 2. So finite is equal to q by twice epsilon naught, and sin theta का इंटीग्रेशन होता है minus cos alpha from 0 to theta. So this implies finite is equal to minus q by 2 epsilon naught cos theta minus cos 0. So cos 0 is what? 1. Are you able to get me? समझ में आया बात? So this implies in a simple term that phi net is nothing but q by 2 epsilon naught 1 minus cos theta. Is that clear? And cos theta is what? Base by hypotenuse, isn't it? So phi net ultimately it is written as q by 2 epsilon naught 1 minus x by root under r square plus x square, which looks similar to some equation, and that is nothing but this is the electric field with the disk multiplied with the charge. That's all. Is that clear? Um, uh, can I which part I should explain? The whole part or what? Uh, this one. This one. So simple. See, simple. D phi is EP. dA is what? 2 pi r into dr, which is 2 pi y into dy, isn't it? So I just replaced y value over here, that is x tan alpha, and then the dy. So I need to differentiate dy or not, because y is also varying with respect to alpha. So dy by d alpha, basically dy by d alpha will be what? X sec square alpha. So dy will be what? Simple, x sec square alpha into d alpha. Are you able to get me? That's, and then I just put it over here, which becomes x will get cancelled, sec square get cancelled, so it will become kq into 2 pi tan alpha d alpha. Is that clear? Yeah. So see, point is very simple. See, I kept my disk, then in front of it I kept my charge. ठीक. अब इस चार्ज की वजह से तो बहुत सारे ऐसे ऐसे इलेक्ट्रिक फील्ड्स आ रहे हैं ना, मुझे फ्लक्स निकालना था. तो हमारे पास तरीका क्या है? आई कंसिडर one a small ring which has some thickness which is varying with respect to angle theta with respect to q. ठीक है ना? इसके वजह से एक इलेक्ट्रिक फील्ड होगा. उस इलेक्ट्रिक फील्ड के दो कंपोनेंट्स, इस कंपोनेंट का फ्लक्स जीरो है कि नहीं, इसका एग्जिस्ट करेगा. अब पॉइंट आता है कि इसमें से कितना निकलेगा फ्लक्स. तो फ्लक्स क्या होगा? जो भी छोटा फ्लक्स निकलेगा विच विल बी इक्वल टू ई कॉस अल्फा. ऐसे डायरेक्टली मैं लिख सकता हूँ क्योंकि ई कॉस अल्फा का ही कंपोनेंट है कि नहीं. So E cos alpha into area of the small ring which you have considered. ठीक, then you put it and then you just integrate it. Are you able to get me? So you will get the answer in terms of this 0 degree till theta degrees, but theta can be written in terms of base by hypotenuse or not. So that's what I have written. ठीक. Is that clear? Okay, so this can be the most toughest question which can be asked to you in terms of flux or something like that. ठीक है? Is that clear? Okay, so we've calculated, we got to know how to find the flux for the given electric fields. We did so many cases. Now, let us bring this, let us just understand this with one of the most important rules of physics, and that is known by a name called as Gauss law. है ना? Now, the question was that what was missing that we brought this principle? The missing part, you can look over here, that let's suppose in this ring also can, there was a possibility that there some charges can also exist over there, or not. And due to the charge itself inside some region, some kind of flux can be considered from that region or not, from a specific area. So in reality, if you look over here, flux talks about, the flux formula is E and then multiplied with the area. Yes? Huh. But for a charge enclosed over here, this principle will not be valid. Means this principle will vary as I consider different areas or not. So to remove this discrepancy in a much more greater sense, the Gauss law was brought, which could talk about what happens when the charge is enclosed within an area, void or not. So a statement is very simple. So based upon this, the Gauss law statement came. It says that net electric flux through any net electric flux through any imaginary closed surface known as Gaussian surface ठीक, is 1 by epsilon naught times of net charge enclosed by that closed surface. सिंपल स्टेटमेंट, वेरी सिंपल स्टेटमेंट बोल रहा है कि सर अगर मान लो आपने कोई एक सर्विस माना, अभी बोल रहा है कि ये इमेजिनरी है, ठीक है, लेकिन अभी ऐसा थोड़ी ना कि इमेजिनरी है तो कुछ भी मान रहे है कि नहीं. तो इमेजिनरी में हमें मानना है क्लोज सर्फेस. किस तरह का सर्फेस? क्लोज. और अगर उसके अंदर से, अगर मान लो उस क्लोज सर्फेस के अंदर if there is any kind of charge inside that closed surface, then the flux at any point is simply nothing but q by epsilon naught. How much is that? Q by epsilon naught. Now, why he told about the imaginary surface? There is a reason for that. He is saying that I'm not saying that this charge can have only one surface. Basically, for this charge, I can consider this surface also. I can consider this surface also, isn't it? कुछ भी है कि नहीं? But according to the previous principle, the area varies, the flux will vary, isn't it? But Gauss law says that as you have considered an imaginary surface, so that is why for all these surfaces my flux is same, which is q by epsilon. Are you able to get me or not? There is a term used over here, imaginary, just to understand that conflict between what is reality and what is non-reality. Actually, the charge is only one in that area, so the flux will be linked with that charge itself, isn't it? So how much, the point is simple, Why it is saying constant? Because the number of field lines which will be generated in that region will actually balance with that same number of field lines in the other region and same number of field lines in the other farthest region, isn't it? But what will happen that the separation of these field lines will increase. So the intensity of, although the charge will decrease, means the field intensity will decrease, but the number of field lines is not decreasing now. So that is why it is saying that for all the surfaces, my flux should be actually same for a enclosed charge, not for a open charge. For which kind of a charge? Uniform, because my field lines are uniform. Are you able to get me? And that's why he is saying about imaginary closed surface. The difference is simple. See, here the field is different, here the field is different, here the field is different. But the number of field lines in this region is same with the field lines in this region, is same with the field lines in this region. Just by increase in the separation, field intensity is decreasing. So according to principal, flux should decrease. But actually the flux is a relation of field lines. So that's why we need to create a law for that to make my flux to be constant. And that's why Gauss law was brought. Are you able to get me or not? Got it? So this is what it is saying, that if I have an imaginary surface, so point is simple, I'll write that as the field lines, number of field lines are similar through considered a considered surfaces like A, B and C. So the flux should remain constant, right or not? And this is why Gauss law is brought. To understand that field flux through any closed imaginary surface should be fixed. Right or not? Okay. Are you able to get me? Nice. So look over here. See. So let us. You got to know why Gauss law was brought, isn't it? And you can see that as the fields are changing, although the flux is constant. Got it or not? So this is why the field relation was given. That as flux is q by epsilon naught, and due to that flux we know that it will be sum of all the electric field in that region, isn't it? So that must be equal to E dot D. Is that clear? So a Gauss law was a interpretation, means it was a interpretation to make this kind of discrepancy which was there earlier, to make it fixed. Okay. But then this Gauss law is valid, means this flux rule will be only valid for closed surface. So first point, Gauss law is valid. Only for closed surfaces. Second point, Q in is my charge enclosed in the क्लोज सर्फेस। ठीक, चलो आगे बढ़ सकते हैं। So let's suppose take an example. Let's suppose if I have any arbitrary closed surface, okay, and in that some charges are there like q1 minus q2, q3, and outside some charges are there q4 and q5. And if I have drawn this closed surface like including three charges, okay, so the flux over here will be only defined for those kind of charge which are enclosed. Are you able to get me? So net flux will be what? Charges divided by epsilon. Is that clear or not? Means the outside charge, although their field lines are there over here, got it or not? But they will be not considered for the flux case. Is that clear? Yeah, because they are not inside the Gaussian surface. Now it's your question, means I'm asking this question, why is like that? Although their field lines are present over here, why it is not considered under the flux inside the Gaussian surface? It's your task. You have to find, read H.C. Verma. It's given perfectly in H.C. Verma. The statement why it is not considered. Are you able to get me? ठीक, चलो तो आगे बढ़ते हैं. So let us understand on how many points this flux depends on. So flux, according to Gauss law, flux depends on mainly 3 points. First point is uh, like, okay, let us write two things. Flux does not depend on we know, but on what it will not does not depend on. Yeah, first thing, outer charge of the Gaussian surface, ठीक है. Second thing, position and size or position of inner charge, it does not matter. Just, yeah, because it's an imaginary surface we are counting, void or not. Third thing, flux will does not depend on shape and size of Gaussian surface. That's what we discussed earlier, because it's an imaginary surface. Is that clear? Are you able to get me? Now the question arises that how to define, see, I can define the Gaussian surface, I can define the flux, but flux is also related with electric field at a particular point, isn't it? And if it is non-symmetrical, then electric field is totally different at each and every point, isn't it? So how to find the electric field at any point if a Gaussian surface is given? So let's suppose if there is any Gaussian surface like this way, okay, then I need to first define a small area over here because this is a non-symmetrical. Got it? So this a small area will be also, since it is a vector quantity, it will have a direction along the normal, correct? And at over there will be some electric field, isn't it? So then the particular electric field, remember that the flux is defined on my Gaussian surface. It's not defined internally, got it or not? So flux will be equal to integral E dot dA, and closed loop integral means I need to take a whole sum of these fields and then add it to get the net electric field on the Gaussian surface. Are you able to get me or not? Is that clear? So remember, E is different, E dot dA is different. E dot dA means flux, E means electric field due to all these charges at that point. Are you able to get me? So look over here, see. So that means the question arises that since you are writing many charges and their electric field, then there should be some dependency, isn't it? So E vector depends on many quantities. First quantity is on all the charges which are present inside the Gaussian surface. Second thing, position of all charges. Okay, is that clear? So E depends on the charges and position of all charges, but integral E dot dA, which is my flux, is independent of outer charges and position of charges. So that means although my E depends on this and E dot dA is independent on this, that means one thing is very very common, that remember that integral E dot dA, which is equal to Q enclosed by epsilon naught, is dependent on charges enclosed inside the Gaussian surface. Yeah, is that clear? ठीक है, चलो तो इतना दूर क्लियर हुआ, इसको पहले समझ लो, कुछ दिक्कत हो तो पूछ लो, फिर अपन आगे बढ़ेंगे. Yeah, dependent on enclosed charges, independent of outer charges, independent of shape and size of the charges, although the electric field depends on inside charges. Got it or not? But this is what is very good thing about flux. It is, this is the best thing about flux, that it makes whole quantity to be independent of position of charges. Got it? Yeah, electric field is different. Now, one more property let us discuss. Now let us consider that one charge is placed, Q2, Q1, and some kind of charge Q3 is placed, and I draw a Gaussian surface like this way. Means a Gaussian surface passing through one of the discrete charge. ठीक? So point is very very simple. Remember that this is a fire alarm over here. Okay, buzzer of fire alarm. Remember that Gaussian surface. If Gaussian surface passes through any charge, any discrete charge, not a continuous charge, any discrete charge, then avoid using Gauss law. Although this is not possible, but we should avoid. Got it or not? Yeah, it is a hypothetical case. Yeah, because there is a reason for that, because you do not know how much charge is enclosed within the closed surface, isn't it? Like here, if Q3 is given, which is present over here as half and half. So how much charge is enclosed within the surface we do not know, na? Because we do not know how much charge is enclosed within the Gaussian surface. Is that clear? ठीक है, आगे बढ़े. Next point and last important point. So there was a consideration of like continuous means a discrete body. Sorry. Now let's take an example. What happens if the Gauss law passes? Means if the Gaussian surface passes through some of the continuous body. ठीक है? जैसे ऐसे पास हो रहा है ना? अब इस अगर ये रॉड है तो इसके ऊपर कुछ ना कुछ प्लस चार्ज क्यू होगा, है ना? मान लेते हैं. और लेंथ ऑफ द रॉड इज एल. ओके. The question arises what we will consider, isn't it? So look over here. So there is a rule for that. The rule is simply it is saying that if Gaussian surface passes through a continuous body, okay, then we should consider for the amount of charge enclosed in the Gaussian surface. Yeah, look over here. See. So for this rod, there is some length x for which the charge, some charge is enclosed over here or not. Yes. So Gauss law says that for continuous body, you can definitely consider the particular case of finding the charge enclosed or flux through the surface by considering only the charge which is enclosed inside that Gaussian surface. Are you able to get me or not? So look over here. Let's suppose if I want to find the flux through this. So simple charge enclosed will be how much? Simple. So what I will use? I want to find the charge in this region or not. And this is a linear rod. So I will use lambda. Lambda will be total charge by total length. And I want to find charge enclosed in that region. So for charge enclosed, the length is x. So simple. Charge enclosed will be how much? Total charge by length into x. Are you able to get me? So flux is simple. What is flux over here for this? Simple. Charge enclosed is q by L into x into epsilon naught. Is that clear? Are you able to get me? Is that clear or not? That. Hmm. Yes. ठीक है? So these are some of the rules of Gauss law which we utilize to understand too much about the electric field or fluxes through the given surfaces. ठीक है ना? Yes. So let us solve some problem based upon these, and then we'll move back. ठीक है? Okay. Question बोल रहा है. First question, which is typically always asked, that let's suppose if I have a cube, ठीक, and question is simple, very simple. Okay, that 100. Let me just. Can you hear me? Okay. So question is simple, like find the flux through given cube if a point charge q is kept at first. Okay, so I'm marking these points. This is A, B, C, D, E, F, G, and H. So first case where the charge is kept center of Q. Okay. Second case, center of surface EFGH. Third case, center of H, center of H, HG. And fourth case, corner G. Tell me. Find the flux through the given cube if a point charge is kept at four different places. So you will get four different answers. So tell me what will be those four different answers. Yeah. Think. It is very easy if you think. Acha, what happens if I place at the center of cube? First case, we place it over here. Acha, for this charge, the electric field will be like in that three-dimensional space or not? Yes. So let's suppose if I consider this surface, so it will pass from this surface also, this and all, and that too in symmetrical way, isn't it? So that means simple सी बात है अगर हम ध्यान से देखें तो total flux through the cube will be how much? You can consider a whole cube as a Gaussian surface, isn't it? So flux through the cube will be how much? Q by epsilon naught. And I'm asking through the cube, isn't it? Huh. Like, and if someone would have asked find the flux through the surface, one of the face, then flux through one of the face will be what? Since the whole surface is divided into six parts, isn't it? Isn't it? Six part or eight parts? Six faces. Six faces are there, isn't it? So if there are six faces, then this whole flux will be divided into six faces in a symmetrical way. Epsilon. Are you able to get it or not? Yes. So flux through the cube is always q by epsilon naught, but the through the face it is almost q by 6 epsilon naught. It is by epsilon naught, which is also known as flux through the any surface if a charge is placed at center. Is that clear? Hmm. Do the second case. Center of surface EFGH. Now think. Try to think. How come it will be q by 6? Mm-hmm. No. Think. placed at the center of phase EFG. Think, Balak, think. It's an awesome case I have given to you. Take. Okay, I'll show you one diagram. 1 minute, I'm stopping. Yeah, I'm just stopping presentation for 2 minutes. Try it. It's very easy if you try now. It's very easy. Think like, अच्छा एक बात बताओ. If I place a, like you only think, if I place any kind of charge, okay, 1 minute. Wait. Just let me download. Ah, can you see the screen? Now you can see. Yeah. Now see, think of one case. Think of this as an example. Okay. I'll place it on next page. Wait. Delete. Okay. Think of this case. See, if I am placing any charge at any of the face, see, then that charge, for that charge, how it will be the appearance? See, some part of the charge will be inside one of the cube, isn't it? Have you studied that solid state physics, solid state chemistry? हेलो. ठीक है. तो तुम्हारे उसमें बताया जाएगा कि when I place on the edge means when I place on one of the face, then half part of the charge is outside and half part of the charge is inside. ठीक है. If I place any charge on the face, then half part of the charge is outside and half part of the charge is inside, because I'm trying to place it in an equal fashion, isn't it? Okay, so basically we can imagine like there is another cube on the topmost region of that charge, for which some kind of electric field lines will pass through it or not. If see, your idea is what? To write the flux, you need to close a charge. You need to enclose a charge, isn't it? Total charge should be enclosed. So the question arises that half region, yeah, so that another half region of the charge will be enclosed in what way? I need to construct another such kind of a cube to enclose that charge which is placed on the surface. Are you able to get me or not? Is that perfectly clear? Yes. We can't use Gauss law, na? Can you use Gauss law? Hmm. So then, from which surface the flux will pass? So then, from which surfaces the flux will pass? See, for this parallel surface, for this parallel face, the electric field lines are perpendicular to my normal or not. So the flux through that will be how much? Zero, isn't it? Similarly, if you consider all these four faces nearer to that charge, for them, what will happen? How the electric field lines will pass through them. Electric field lines will be almost parallel to their surface, isn't it? So that will make the particular flux to be almost zero. Only this bottom part and top part will be that part from which the electric field lines will emerge perpendicularly, isn't it? Agony. So there are only two faces from which the electric field lines can pass perfectly. Are you able to get me? So therefore, instead of considering the face, I have been asked to find the flux through the cube, isn't it? So look over here. For the second case, as if I place on surface, then there are, first thing is only half part of the charge is there inside this. And to enclose, I need to consider two kinds of cube or two kinds of same area to enclose this charge. So therefore only, yeah, so only how much is there? Half part of whatever is the enclosed previously is present over here as flux or not. Is that clear? अरे सिंपल एक बात बताओ. What is the total flux through the system? Flux through the system is q by epsilon naught. Yes. Now how many? Yeah. How many such? How many such cubes are there? Two now. So through one cube it will be how much? Q by two epsilon naught. Yeah. So it is how much? Some. Yes. Yeah. Now, most important thing, if you would have asked you that Q flux through any of the surface, then what would have been your answer? Q by 6. Why 6? Mm-hmm. Any, like I'm talking about any of the face. I want, if I place the charge over here on one of the face, then what is the flux through any of the other surfaces? So the point is here, remember that you have to say that, sir, here the case is not symmetrical. For every surface, the flux is going to be totally different. Are you able to get me or not? Through this surface, the flux is zero, isn't it? But through other surface, means other four surrounding, it is same, but for the down part, it is totally maximum, isn't it? So I have a, like you can say, unsymmetrical case over here. So that's why we can't solve it in a normal way. You will have to use integration and so much a lot of process to understand this, right or not. So that's why we will not define this. Is that clear? Okay. Just like previous case, the flux was distributed equally along all faces or not. But here, is it possible that the field lines will pass equally along all the surfaces? No, because it's not in symmetrical configuration, isn't it? Means if I place the charge over here, then how many flux are passing through this surface? How many field lines are passing through this surface? How many field lines are passing through bottom surface? How many field lines are passing through sideways? We do not know, isn't it? It's requires a lot of process, but in some question like in JE 2015 they told like if the flux passes through all the surfaces in a like you can say symmetrical way, then the flux through one of the surfaces is zero, but for other five surfaces it can exist or not. So for other five surfaces if we take, okay, then it will be how much? Half of this means 1 by 5th part of this flux through one cube, isn't it? So that is 1 by 10 cube epsilon. If you have to write over here, if the field lines are symmetrically distributed, is that clear? It will be mentioned in your question. No, no, here it is not mentioned, but that's why I told you I have two answers. For non-symmetrical distribution, no answer is there. But for symmetrical distribution, I have an answer. Got it or not? Take. Do the third case in the similar sense. Hmm. So basically, remember, I'm telling you the trick. If I place at the center of A's in one cube, only one fourth part is present. How much part is present? So to surround the whole charge, I need to construct three more cubes sideways of that, isn't it? So flux through the system will be how much? Q by epsilon naught. But flux through any one of the cube will be how much? Q by 4 epsilon naught. Are you able to get me? Take. So the answer is very simple. Third case, flux through system will be uh, Q by epsilon naught. But we need to construct uh, Q by 4 epsilon naught. Through any of the phase, it's your task to calculate it. Okay? ठीक है? कर लोगे? हाँ, it's a symmetrical surface. Okay? So look over here. I'll give you one hint. See, for the symmetrical surface, see, for these two surfaces, the field lines will be parallel to it, isn't it? So for them, the flux is zero. So how many surfaces are left out? One, two, three, and four. Only four parts are left out, isn't it? So flux through any of the surface is 1 by 4 part of cube, isn't it? So it will be 1 by 16 cube by epsilon. Okay? Do the fourth case. If I place it on corner, if I place it at any corner, okay? Now if I place it previously, see, in the center whole charge is there. Surface one half, A is one fourth. So corner 1/8 part is there. How much part is there? So 1/8 part of charge is only there. Take in one cube. So simple. I need to construct 8 such cubes over to enclose that charge at the vertex or not. So flux through the system will be Q by epsilon naught. But flux through the cube, yeah, so Q by 8 epsilon naught. Are you able to get me? And then when I consider over here, then three faces, the field lines will be parallel, isn't it? One top, one side, and then one back side, isn't it? So how many faces are left? Three more faces are left, isn't it? So flux through one of the surface will be one third of q by 8 epsilon naught, which is 1 by 24 q by epsilon. Is that clear? समझ में आया? चलो आगे बढ़े. So this was our PhD on Q based on Gauss law. ठीक है ना? ठीक. Okay, so let us move on to perfect utilization of Gauss law and let us do some derivations. So earlier we discussed the cases of ring, disc, straight rod, isn't it? And our cylinder, spherical sail, and all these 3D hollow sphere and solid sphere we were going to discuss after the Gauss law description, isn't it? So that's what we are going to do. Okay. So give the heading derivation of objects using the Gauss law for electric field. Is that clear? ठीक, हेडिंग डाल देते हैं फर्स्ट केस आवर यूनिफॉर्म charged, uniformly charged, 1 minute, uniformly charged thin hollow sphere. ठीक, इसका दूसरा नाम होता है सेल, जो हम कॉमन भाषा में यूज करते हैं ना. ठीक, फर्स्ट केस है ना. आगे बोलिए, चलो ध्यान से चलो को बोलिएगा. लेट सपोज okay, let us see if this is my sphere. ठीक, now so original, this is inside sphere is your original sphere, okay, which has some radius and it has some plus charges, okay, means it is a charge, uniformly charged, okay. Means the density is uniform, right or not? So let's suppose the uniformly charged sphere. I think I should take a 1 minute. I should take another picture. Basically, I need to take a sphere as white. ठीक है. Okay, 1 minute. Huh. You got the idea that I have an uniform spherical cell of radius r and it is charged with plus charge q. Right or not? Is that clear? ठीक, अब ध्यान से देखो. So it has some charge q. ठीक, अब look over here. I want to find, see, for this charge I can find some electric field at some place or not. Now look over here. If I want to find the electric field at some, there are basically you can see that for this cell there are three reasons. One, lying outside, which is present over here, like at some distance r, small r. Take. And then one surface point, and then at some inside region, isn't it? So I label them, like I label this as P, I label this as Q, not Q, sorry. Take A, take B, and then interior region as point C. Are you able to get me? So first case 1, for exterior region, R greater than capital R, void or not, or point A. Is that clear? Now simple, for this what will be that? What will be the electric field? अब ध्यान से देखा जाए तो due to this charge, the electric field will be in this direction. Correct, isn't it? And that electric field at that point, I call electric field at A will be how much? Simple. E will be equal to 1 by 4 pi epsilon naught Q by R square. अरे कुछ तो बोलो है ना, यही है ना? Now look over it. This electric field, if I'm considering this a small area of this particular region, हाँ, so छोटा एरिया, उसके लिए जो डीए होगा वो इस डायरेक्शन में होगा, सेम डायरेक्शन में होगा इलेक्ट्रिक फील्ड के, है ना? सर्कल है तो द पर्टिकुलर नॉर्मल इज अलोंग द डायरेक्शन ऑफ इलेक्ट्रिक फील्ड ओनली, रेडियली होता है कि नहीं? सो दैट मीन्स द एंगल बिटवीन डीए एंड ई इज हाउ मच? जीरो, है कि नहीं? So therefore, let's suppose if I define the flux, a small flux due to that dA, it will be what? This E 1 by 4 pi epsilon naught Q by R square, and cos 0 is how much? 1. So just dA, isn't it? And then I need to integrate it to get the total flux. But that total flux is how much? What will be that? Tell me. Achha, why I am writing this E as Q by 4 pi epsilon naught R square? Wait. So this, if I want to find, अरे मैं क्या कर रहा हूँ, मेरे को इलेक्ट्रिक फील्ड निकालना था ना. So this d5 will be what? E dot dA, isn't it? And then I need to integrate to find the total flux or not. But flux, if I create this as a Gaussian surface, it is equal to what? Charge enclosed by epsilon naught. तो E की वैल्यू क्या होगी? अच्छा, अब ध्यान से देखो. If I take integral dA, and at each and every point if I take the integral dA, so it will be total surface area of this whole Gaussian surface or not, which is itself a hollow sphere, isn't it? So area, surface area of a sphere is how much? 4 pi R square, which is equal to charge enclosed, which is Q by epsilon naught. So therefore E at point A is simply the formula Q by 4 pi epsilon naught R square. Is that clear or not? Are you able to get me? So that's how we people actually say that Coulomb's law is like sorry, yeah, the basically electric field is the verification of Gauss law. ठीक? Because for every case the Gaussian surface remains same and the electric field remains same. Are you able to get me? So basically I got my this as electric field. Case B, on the surface means R equal to capital R, which is region B. तो सिंपल सी बात है, वंस अगेन तुम करोगे तो ये जो सरफेस एरिया आएगा वो इस स्फीयर का पूरा सरफेस एरिया होगा, which is 4 pi into capital R square, isn't it? A into 4 pi into capital R square is Q by charge enclosed is once again Q by epsilon naught. So E is equal to 1 by 4 pi. This will change to capital R square Q by capital R square. Are you able to get me? But imagine the case interior in the inside region. ठीक. Case third. Inside the inside region. ठीक है, inside region. Inside region means R less than capital R, isn't it? ठीक. अब ध्यान से देखो, इसको अच्छे से देखना, बहुत इंपॉर्टेंट चीज समझा रहा हूँ. Now when you consider the inside region for R means R less than capital R, you need to construct a Gaussian surface over here or not, which will be spherical in nature, isn't it? But how much charge is enclosed within that region? See, if a conducting body is there, so charge will remain on the surface, isn't it? Inside there will be no charge now because it is a hollow sphere. Are you able to get me? So inside there is no charge. That means Q enclosed is how much? 0. And if charge enclosed is 0, simply what will be the equation? E into 4 pi r square for inside region, that is 0 by epsilon naught. So electric field inside the sphere is how much? It is how much? 0. Is that clear? So we got to know that inside the hollow sphere the electric field is 0. On the surface it is 1 by 4 pi epsilon naught q by capital R square, and at the exterior point it is q by 4 pi epsilon naught R square. And as you increase the distance, electric field will start decreasing, isn't it? So therefore I can plot the graph of electric field with respect to distance. Electric field with respect to distance r. So look over here, till surface r the electric field is 0 or not? Inside region the electric field is 0, and suddenly at the surface I have the maximum electric field, which is given as kq by capital R square, isn't it? And then that electric field starts to decrease. So it is drawn like this way. Okay, it is drawn like this way. And then the electric field starts to decrease for outside region. Okay? So this is the diagram for our electric field, for the variation of electric field for the hollow sphere. Is that clear? Are you able to get me? चलो इसको लिख लो, फिर अपन आगे बढ़ेंगे. इनको देख लो. If you have doubts, you can ask me. Hmm. 1 by r square, correct. ठीक है, चलो आगे बढ़े. सेकेंड केस. अब हम चल रहे हैं सॉलिड स्फीयर पे, है ना. Now in the first class I defined two kinds of things, conductors and insulators, isn't it? So what happens with the conductor and what happens with the insulator if I charge them? Yes, I told you about that distinction, no? Do you remember it? For what the charge will appear on, and for insulator the charge remains everywhere, evenly distributed, uniformly distributed, isn't it? So, 1 minute. That's what we are going to do today. Give the heading. We will, since see hollow sphere, whether it is conducting non conducting बात बराबर है कि नहीं? क्योंकि चार्ज तो हरदम सरफेस पे ही रहेगा, इनसाइड में तो कोई मटेरियल नहीं है ना. So basically whatever we have done, this is applicable for SLE globe. This is also applicable for non conducting hollow sphere, है ना. So right now we will pick up the case of a conducting case, a non-conducting case. Then we will discuss about the conducting case. Actually, the conducting case is similar to our this case of non-conducting. We will discuss that later on. ठीक है? तो heading डाल दो uniformly charged solid sphere which is non-conducting in nature. See, you can consider that this is just like a nucleus, okay? where charge is uniformly distributed. ठीक. चलो देखो ध्यान से. Now this is my solid sphere. ठीक है ना? So we will take the first case. Bring this over this side. Okay. Case 1 at exterior region. ठीक. अच्छा. Let's suppose this has radius r. ठीक है. And the charge which was given was capital Q. ठीक है ना. अच्छा, जब हम एक एक्सटीरियर पॉइंट मानेंगे, लेट्स सपोज इफ आई कंसीडर सम एक्सटीरियर पॉइंट, है ना, so for which will be located at some distance, isn't it, from the center. So what I need to do for that exterior point, I need to generate a Gaussian surface, then I can only apply Gauss law now. So if I generate a Gaussian surface, if I generate a Gaussian surface, that will be also spherical in nature, isn't it? Now look over here. For this Gaussian surface, it's if the charge is Q. So for this exterior region, the charge enclosed will be exactly Q or not. That's correct. So electric field will be given as what? Simple. E into, if I do the integration of all that, then again I'll get the area to be a sphere, isn't it? And a sphere has area 4 pi r square. That must be equal to charge enclosed, which is Q by epsilon naught. So E at exterior region, or I call this point as point A. So E at A is simply normal formula 1 by 4 pi epsilon naught capital Q by r square, है ना? At the surface, yeah, correct, a small r square. ठीक है ना? Now if I consider the surface, case 2, on the surface r is equal to capital R. So when I will draw the Gaussian surface, it will still cover the same charge Q which is inside the surface or not. But the area will change, isn't it? So it will be E into 4 pi capital R square Q by epsilon naught, और E at surface मान लो ये B है, so it is 1 by 4 pi epsilon naught capital Q by R square. Are you able to get me? Now, what happens when I take a small result? That's a big question to understand, isn't it? है ना? What happens if I just consider instead of a bigger, can I have more thickness of this? No, 1 minute. I am just looking for much more depthness of this particular. No such thing as that. Okay. So let's suppose if I take a Gaussian surface inside the sphere, है ना? This is my Gaussian surface. Means if I want to find at internal region, I need to construct a Gaussian surface, isn't it? And this Gaussian surface is located at some distance r from the center. ठीक? Yeah, and I want to find the field over there. Now you only think, see, the whole charge, it is a non-conducting body. So पहले पूरे सिस्टम के ऊपर चार्ज क्यों था, है ना? अब तुम खुद सोचो, अगर तुम उसके इंटरनल रीजन पर चल जाओगे और तुम जब ये गॉसियन स्फीयर ऐसे बनाओ, तो इसके अंदर जो चार्ज इंक्लोज होगा, इट विल बी ड्यू टू दिस रीजन, इजंट इट? It will be due to this shaded green shaded region, means the charge enclosed will not be same, because in this region, since it is evenly distributed, the total charge will be distributed over whole surface or not. तो ध्यान से देखो, जैसे मतलब मैं एक छोटा सा एग्जांपल ले रहा हूँ, जैसे मान लो, if I consider a rod, now there were total, it is a non-conducting body. Which kind of a body? So on the whole surface, let's suppose I have 5 coulombs of charge. How much charge? And this length is of 5 meter. So that means what? If it is a non-conducting and uniformly distributed, that means at 1 meter I have 1 coulomb of charge or not, because it is a non-conducting body and charge will be fully distributed, isn't it? Are you able to get me or not? So बस बात यही लॉजिक मैं यहाँ पे भी अप्लाई कर रहा हूँ कि सर स्फेयर है, तो पूरे स्फेयर को अगर मैंने चार्ज किया तो टोटल चार्ज Q will be distributed all over this space. Now if I consider a small region out of it, so then the charge enclosed will be totally different, because here the charge content is different. Are you able to get me? So the question arises now that I need to first find charge enclosed within that region. Yes, so look over here. So that's what we are going to see, that how to find the charge enclosed. Now it is uniformly distributed and charge is given. So density is uniform, and solid sphere, 1 minute, and solid sphere is an example of 3D body. So I need to use rho, isn't it? So see that. So rho is what? Total charge by total volume, which is 4 by 3 pi capital R cube. That is my rho of full sphere or not. And for this small sphere also the rho will be same, isn't it? So consider inside this small sphere the charge enclosed is a small q or q in. Take. So that q in, that means since rho is same, so for this sphere also the volume should remain same. So q in by volume of that sphere, which is 4 by 3 into pi into a small r cube. Are you able to get me or not? So Q enclosed in terms of Q is how much? 4 by 3 pi, 4 by 3 pi cancel. So Q enclosed inside that Gaussian surface is capital Q into a small r cube divided by capital R cube. Are you able to get me? Is that clear? Got it? Just like this rod case, है ना? तुम ही सोचो, मैंने क्या बोला? 5 coulomb charge is there, 5 meter is there. So in 1 meter, 1 coulomb. I ask you how much charge is there in 3 meters. So what you will do? So how you said 3 coulombs? First, you found out the charge of 1 coulomb or not. How? By total charge by total volume, it will give the total charge per unit length or not. And then you multiply it with the required length, which is equal to 3 coulombs, isn't it? Now it is a 3D body, so what I will do? Total charge by total volume, which is 4 by 3 pi r cube, multiplied with the required volume to find the total charge in required volume or not. Simple, but that can be easily related. I will not use that much logic of mathematics. I'll just relate the density. Density is charge by volume, it is a 3D body, and density is uniform, so charge includes can be found easily. Right or not? So therefore I can directly now apply now flux rule. That flux is E into surface area. So surface area of this sphere will be what? Simple 4 pi small r square for the inside region, isn't it? Which is charge enclosed. Here charge enclosed is different, so it is q by q small r cube by capital R cube into epsilon naught. That is why for uh, I didn't wrote case. Yeah, so this was still surface and this is for inside region. Case 3, go ahead or not? For R less than capital R. Is that clear? So therefore E at point, what we say, at point C is simply R square will get cancelled, it will become R. Q small r divided by 4 pi epsilon naught into capital R Q. That's your electric field inside the solid state. Word or not? So on the surface, outside it is same Q by R square. Inside it is varying with respect to this R. Got it? So therefore, look over here. If I want to draw the graph of E versus R, ठीक, अब ध्यान से देखो. So for inside region, at the center, if R is zero, electric field will be zero or not, है ना? And as R is increasing, since E is varying linearly, that means as I am going away from the center till the surface, the electric field is increasing linearly with R. है कि नहीं? Surface पे maximum, which is Q capital R by 4 pi epsilon naught R square, है कि नहीं? And then it starts to vary inversely, which is decreasing. Are you able to get me? So that is why the graph of this is drawn like this way. How? First it varies linearly and then it varies inversely. Are you able to get me? Got it or not? So this is my electric field. Sorry, actually E inside, which varies linearly, and E outside, which is inversely proportional to 1 by R square, और इसका maximum value तुम्हें मालूम है, which is KQ by capital R square. Is that clear? चलो इतना तो समझ में आया नहीं यार. So this is how we calculate the electric field for our case of uniformly charged non-conducting sphere. Are you able to get me? Now look over here. What happens if it is a conducting body? So let's suppose if I take a sphere which is conducting, है ना? Think. See, it's very easy. If a sphere is a conducting body, then inside it once again the charge will be not there, na? The charges will appear on the surface only. अरे कुछ तो बोलो हाँ है ना? अगर मान लो टोटल चार्ज है तो ये क्या होगा? It is simply KQ by capital R small r square. Surface पे KQ by capital R square, but inside there is no charge, so electric field will once again become zero or not. So is my conducting solid sphere is behaving like a hollow sphere, isn't it? So that's why हाँ, yeah. So simply we will write that this is also applicable for the case of solid sphere, solid conducting sphere. ठीक है. So you have to be very very cautious during the exams, whether it is non-conducting, conducting. You have to take care of that. सब स्पेसिफाई करेंगे एग्जाम में, सब स्पेसिफाई करेंगे. इज दैट क्लियर? हम्म. Otherwise you will get the negative marking definitely. So today we talked so much about Gauss law and its properties, and we calculated the electric field for two cases. Similarly, tomorrow we will first discuss the potential for two different cases and then we'll move ahead. Is that clear or not? ठीक है. तो कल भी 1.5 hour का क्लास, आई एम सेविंग दैट another half hours for a big class of dipole moment which I'll complete in one day. Okay, ठीक है, चलेगा ना? चलो फिर तब तक